So the other thing that I've never made a video for is the reaction types. And what we're looking for is patterns in the chemical reactions that tell us what type it is. There are 5 types that we learned about. There might only be 4 in this video: synthesis, decomposition, single replacement, and double replacement. The key is identifying how many reactants and products you have, and then looking at what those reactants and products are. The first type of reaction is a synthesis reaction. A synthesis reaction is when 2 reactants combine to make a single product. And the key to identifying the single product idea is if we look over here at the product side of our equation, there's no plus sign. When you have no plus sign on the product side, it is a synthesis reaction. And if we look at these 2 examples that I have at the bottom of the page, again, over here on the product side, there's no plus sign. In the second one over here on the product side, there's no plus sign. When you have no plus sign on the product side, you are looking at a synthesis reaction. The opposite of a synthesis reaction is a decomposition reaction. This is when one reactant breaks down to form 2 or more products. One reactant making 2 or more products. And again, whenever you have one of something, there will be no plus sign there. So this time we have no plus sign on the reactant side. And again, if you look at our examples down here at the bottom of the page, there's no reactants on the reactant side there. There's no plus sign on my reactant side there. So again, 2 types of reactions that have no plus signs. Those are our synthesis and decomposition. If you have no plus sign on the product side, it's synthesis. If you have no plus sign on the reactant side, it's decomposition. Everything else we're going to see is going to have a plus sign on both sides. Starting with single replacement. In a single replacement, you will have a plus sign on both sides of the arrow. What's going to make it a single replacement reaction is that you're going to have one element and one compound on each side. So one element on each side, and you're going to have one compound on each side. Now, how do you tell the difference between elements and compounds? You look at the number of capital letters. An element has just one capital letter, so Mg is an element, and H is an element. Only one capital letter in each one of those. A compound will have 2 or more. So HCl has 2 capital letters. MgCl2 has 2 capital letters. So again, you're going to have one element and one compound on both sides. The double replacement reaction is pretty similar. We have a plus sign on both sides, but the difference is we're going to have 2 compounds. We have 2 compounds on our reactant side. We have 2 compounds on our product side. And again, how do you know it's a compound? Number of capital letters. A compound has 2 or more. HCl has 2 capital letters in it, so it's a compound. NaOH has 3 capital letters in it, so it's a compound. NaCl has 2 capital letters in it, so it's a compound. H2O has 2 capital letters in it, so it's a compound. Again, single replacement, one element and one compound on both sides of the arrow. Single meaning single compound on each side. Double replacement has 2 compounds on the reactant side, 2 compounds on the product side. Double meaning 2 compounds on each side. The last type of equation I do not have one of in this particular set of slides, and that is a combustion reaction. And it will not fit the format of either the single replacement or the double replacement. Again, in a single replacement reaction, you have one element and one compound on both sides. In a double replacement, you have 2 compounds on both sides. If we take a look at this combustion reaction, and this is the combustion of methane, also known as natural gas. So it comes out of the gas jets in the lab. Again, single capital letter means that what you're looking at is a element. More than one capital letter means what you're looking at is a compound. So that is an element. And it is the only element in my equation. Everything else in my equation has 2 or more capital letters. That's got 2 capital letters in it, so it's a compound. That's got 2 capital letters in it, so it's a compound. That's got 2 capital letters in it, so it's a compound. And again, a synthesis reaction has one element and one compound on both sides of the arrow. So while my reactant side works, my product side does not. Definition of a double replacement reaction is you have 2 compounds on each side of the arrow. And again, my product side works, but my reactant side doesn't. This does not fit either definition. The key to identifying one of these, if we take off all of the writing here so I can highlight, the key to identifying these is that they will always have oxygen, carbon dioxide, and water in them. The only thing that ever changes is this very first substance. So instead of CH4 in there, you might have C2H6, or you might have C3H8. All that ever changes is what's first in the formula, never the oxygen, the carbon dioxide, and the water. So that's what you look for to identify the combustion reactions. That's it. Now the video should cover everything. Good luck with the test tomorrow.